So in this video, we are going to learn about AC voltages. So AC is alternating current. It's different from DC. So in AC current, the current flows in both directions. So if I give you a graph, it will be more obvious. So I'm going to sketch a voltage versus time graph first. Okay, here is a voltage versus time graph of AC current. This is only one period, it goes long forever. It's a typical sine graph, and as you can see, the graph actually, the voltage can be positive or negative. Okay? So, whether the voltage is positive or negative really is an indication of indication of the direction of the current, meaning that the electrons actually vibrating. Okay? So if I'm going to sketch a current and time graph of AC current, it will be similar. Yep. So both voltage and current, they have the same shape. They're both sine graphs. Okay? But the important thing today is we need to learn how do we describe AC current. For DC current, it's easy. Okay? If you want to describe a current or voltage, we can say we have a DC current of say 20 volts or 250 volts and 5 amps. So, but in AC current, since the voltage is changing, okay, it has a maximum, it has a minimum. Okay? So what we can say is we call the maximum voltage, okay, the peak voltage. Okay? It's labeled V peak. And what we normally call it, we call the voltage between its maximum and minimum, the peak to peak voltage. I will give you an example of it. So peak to peak, and also it has a period. Okay. Say this is 0.1 second. Yep. So this point, the time, the horizontal length, 0.1 second, will be called the period. However, there's more sophisticated ways of describing it, and you need to learn this all. Now, the other important thing is in calculations. When we use calculation, when we're doing calculations in electronic circuits, we never use the peak voltage or the peak-to-peak voltage. We always use something called the RMS value. Okay. To make it simple to understand, the RMS value is basically the average value of an AC current or an AC voltage. So it's calculated using the formula, basically the peak voltage divided by square root of 2. And in your calculations, we use this value. So let me do an example later, but in the meantime, just let me explain. For current, it's the same thing. We have peak current, and we have peak-to-peak current, and we have RMS current. That's it. Also, for the period, there are two ways to describing the period of an AC current or AC voltage. One is period, the other one we call frequency. So frequency is measured in hertz. It basically means how many times in a second. So for instance, well, if we look at this particular AC current, it has a period of 0.1 second. It means for every 1 second, it has 10 period. So 1 divided by the period. So, yep, basically 1 divided by the period, we have 10. It has 10 period. So the current has 10 period in 1 second. We call it 10 hertz. Okay, now, yep, okay, that's done. And let me show you an example. So let me go to Google first. Okay. What's happened is all the electricity from the power socket at your house is supplied as AC current or AC voltage. So let's find out the value of our, well, the voltage of our electricity. Yep. Okay, from Google, let's go to Wikipedia. So from Wikipedia, if we go to Australia, and Wikipedia told me here, okay, in Australia, the voltage of, by the way, they are RMS voltages. Okay, the voltage from our power socket is 230 volts and AC with 50 hertz of frequency. Okay, so if I try to sketch one period of the electricity of the supplied of electricity, I can start from here. Just remember step 1. AC current, it has a sine wave. Okay, so we have voltage, we have time. I can easily sketch a sine wave. Now, then I need to find the peak voltage. However, on the website, I only have the RMS value, RMS voltage, which is average voltage. So from our equation, remember, if you can't remember this equation, write it down somewhere. Okay? So the RMS voltage is peak voltage divided by square root of 2. So using this formula, I know the peak voltage is RMS value times by square root of 2. So if I put it in calculator, so 230 times square root of 2 is going to be roughly 325 volts. So this is the peak voltage. The maximum voltage I can get from the power socket. 325 volts. Now, just always remember an important fact. In calculation of the circuit, we always use RMS values. Use RMS, yep, because this is the average value. Okay, yep, and this means for this AC current, it has the same equivalent effect as the 230 volt DC current, DC voltage. So in calculations, we always use the RMS voltage. We don't use, yep, okay. in calculations. Now, so obviously, let's go back to the graph. Obviously, the minimum voltage would be minus 325 voltage. And if someone asks me, the peak to peak voltage must be 650 voltage. Okay? The distance between these two. Okay? So, yep. Now, we're done for the voltages. Then we need to worry about the frequency, the period. Okay? So, the Wikipedia told me is 50 Hertz. It means there are 50 cycles, 50 period in 1 second. So using the formula, again, if you can't memorize it, put it on your formula sheet. The frequency in Hertz is 1 divided by the period. Okay? So in contrast, P equals to 1 divided by the frequency, which is 1 divided by 50, which is 0.02 seconds. So the whole period is 0.02 seconds. Okay? Half of the period is 0.01 seconds, and the maximum occurs at 0.005 seconds, and here will be 0.015 seconds. So by the end of year, you are expected to do this. So if I tell you somehow I got electric shock, okay, with the AC current in America, okay, let's say one day I go to the US, America, US. Just give me a second. Where's US? Now, let's use Japan as an example here, okay, because I can't find, So, say one day somehow I go to Japan, and in Japan I get electric shock. And in Japan, okay, the current, the voltage they have in their socket is 100 volt with 50 Hertz. Just say 50 Hertz. Okay? So if I tell you those information, you must be able to sketch me a graph like this for one period and finding the peak value and the peak to peak voltage. So this is step 1. Okay.